Right, so this, and before we start, it's quite late in the day. It's 7 o'clock. I have half an hour. Otherwise, there's no point continuing. We wouldn't be able to scratchy corner it. We've got an Amstrad 901. It's a made in Japan one, and you can see how it's been presented, and comes complete with crocodile clips and a Euro CB mic. Okay, this has come straight from an eBay vendor on behalf of a customer of ours. Now this is an end user customer, and he has a vast collection of CB radios, and we service these. So first of all, we'll cut that off and throw that in the bin. That's that done. Do I power it up first? I don't think we will with this one. You just don't know with the Amstrads. So this is a genuine Amstrad. This is the £89.99 one. These work absolutely superbly, unlike the cheap of the copy of the cheap one. Right. So, has it been boy raced? Well, the resistor is... Oh, the resistor's been linked out. Oh, that could be a disaster, because it's going to kill the PA, isn't it? If it's being transmitted. So, we've covered this before. There's this misconception that you do more power if you link the resistor out. Of course, it's there for a reason. And it's not there so much to limit the power, but to stop the PA from taking off and dying. That's a very expensive transistor, the Mitusishi 2SC2166. And it is original. And so, we're not going to power it up with that, like that. So, I'll cut that off, so it's no longer linked out. I may change that resistor. We can lower that if I can't get 4 watts out of set. It's supposed to be 3.3 ohms. We can lower it to something like 2.9 or 3 or something like that to get the 4 watts. But I've shown before, and I don't need to do that demonstration again, on the spectrum analyzer, if we do that, if it's linked out, if you have it on a power meter, it'll do about 7 watts instead of 4. But those extra 3 watts, they're not on 27 megs. They're on aircraft band on 112 megs. So you're not getting better range, you're getting worse range, and you're going to ruin the PA stage. So it's all this ridiculous misconception of the typical screwdriver expert. So I've shown that, demonstrated that. So that is the kiss of death. Well, we'll power it up like that at the moment, just for convenience. The customer's going to use the original connector. I think he's got a power lead which you can share between his different sets. You can use a standard Cybernet power lead, but it won't be polarity conscious, so you'd have to be very, very careful not to reverse polarity it. And we will just check the reverse polarity protection diode is in place. I mean, that's been very, very hot at some time. So we'll get it connected to our power supply, but we're going to tread carefully because it's an unknown. I wonder if this was sold as perfect working order. You know what eBay can be like. I know nothing about CB radio, and you look at previous sold auctions, and they've sold about 20 sets in the last 2 months. I haven't an aerial to test it on. Yeah, right. Alright, power supply on, 9 volts selected. We're powered up. We'll put it on channel 20. Take the Roger bleep off for now. And I'm happy to turn that, we're drawing 120 milliamps. I'm now happy to turn that to 13.8 volts. So there we are, 13.8 volts. So the first thing we'll do is check whether it works on PA, because if that IC has died, when we're going to be in some kind of trouble. I mean, all the ICs in these are quite pricey. The other thing that happens is, as these have got older, the run out of range on the synthesizer's reference crystal, and you end up with this being ruined by people trying to screw it beyond where it can go. So I'll just put the other glasses on and look at it. Looks alright at the moment, fingers crossed. So if we don't get 4 watts out of it like that, then we'll change the resistor. And then of course there's the coil stretchers we've got to look out for as well. So we'll start off by seeing whether it transmits. Oh, right. We don't actually repair mics here. I could start doing it, but it'd be exactly the same fee as doing a CB radio. I have spent hours on mics, and usually for nothing. Oh, so it's snapped off, hasn't it? The rest of it's in there, so there's nothing we're going to be doing with that mic, but it doesn't mean that it's useless, because another scrap mic could come along and say he's got plenty of sets. It might just have the push to talk bar, or he might be able to glue that back together. As far as we're concerned, we'll be doing this on our replacement test mic. Again, it's just wasted 2 minutes. Well, it is still transmitting. It's doing 2.2 watts, but we'll come to that with the paperwork in a moment. So first thing we'll do is plug the speaker into PA. This is the speaker we've got mounted on the wall, and just make sure that PA works. Testing 1 2, testing 1 2, testing 1 2. We've got nothing, haven't we? No. Let's go to crackle from the volume control. So the audio IC is okay. Now what's happened to that then? It's normally the other way around, isn't it? You've got PA and nothing else working. That is a wicked dry joint. Turn the power off. That's not far behind. Power it back up. Well, it's done nothing for us. I'll have to come into the fault finding on that. So looking at the capacitors, there's nothing which is that obvious. That's a little bit heat affected, but then it's had that resistor by it. Right, so we need the service manual to start on the VCO. Okay, well, we haven't got the service manual to hand, so we won't start with the VCO. We'll just carry on with the transmitter at this stage. In fact, we haven't got any tools because I had a club meeting this morning and I took them across to the chapel where we were holding the meeting. I'd like to get deviation done today because I put the test set on behind me, which we're needing to verify at the moment, with the main one being a bit dodgy on deviation sometimes. So we're going to transmit. Let's put picture in picture on for you. So what we're doing, 2 point something watts on the 3 watt scale. Oh, it suddenly stopped transmitting. What's that about? Something's dodgy. It's all over the place. That's the VCO, shouldn't have touched that. Great, that's broken. You know what, I think that was super glued. So there's a dry joint somewhere, it's all over the place. But it would be nice to do the deviation, so we'll just see what I can get. Wallow. It's, oh my goodness. It's definitely a screwdriver. Wallow. It's there. That's 1, 2. Wallow. That's beyond 5. Wallow. It comes to there on the 25 watt scale. So that is 5, 6, 7. So it's 8 kilohertz deviation. It's really useful, isn't it? So, I mean, that preset's nearly at full. I'll turn it to there. We'll set it on this meter and then verify it with the test set behind me. Wallow. So we've done that. I'm going to see whether it's actually receiving. It's Sunday tomorrow, so I've got a lot of church services. We're working as a church organist, so I want to get some of this done today. I can see there's a lot of remedial work to do to get this anywhere near 27.79125. Let's see whether it's anywhere on frequency. yes, it's not far. It's not that far out. See whether it will pull up at all. If it doesn't matter. But enough if it would. So we're looking at just about 100, aren't we? So it's the crystal's starting to come to the end of its life, but I'll probably be fine for another 5 years. So there's no point wasting money changing that at this stage. So it's it won't quite come up, but it's so near it doesn't matter. So let's look. I'll get a sheet of paper. We'll start writing down some parameters. Right, so it's 277912. Sorry, 096, and we've got it to 2779100. Right. Right, let's look at receive then. So put the frequency display back up. It's there somewhere, that's the one. Let's dial that in on the signal generator. So 2779, instead of 125, we'll put 100 in, which is what the thing is working on. And then it's fair, and we're not going to be setting up lopsided. So we'll take that out, and we'll put the test instrument speaker in. And we'll just see what we've got on the cyanide meter. It sounds off frequency, so that sounds like the detector's out. So for 12 dB, we've currently got a very healthy 0.39. For 10 dB, we've got 0.32, and for 20 dB, just coming in at 1 microvolt. Squelched tight. Never opens. And squelched threshold. Is an excellent 0.3 of a microvolt. Right, so see if we can improve on that. So we'll go back to our oscilloscope, put a 100 microvolt signal in, and before we start messing, what we've got on the meter, we've got plus 30, so I just need to write down what it is for S9, and what it is stupidly 3 microvolts. Yeah, 3 microvolts, that's ridiculous. So it should be 100. These clean are going to need spraying as well. Right, so put enough volume in for a sensible display. Start with the detector. Want the best possible maximisation of that, which we've done. So that's now done. So now we'll drop the signal on the cyanide meter, so we're not saturating the receiver. We'll start with the front end. A bit there. Squelch just come in. Definite improvement there. That's okay. That's done. And that's done too. I'll just check the detector. No, that's lovely. Right, let's see what we've now got on the cyanide meter. Is it worse or better? Sometimes moving the detector you end up making the sensitivity worse, but that's how it has to be. So we've now got 0.38 with a corrected detector, 0.32, exactly the same, and an improvement to 20, 0.85. So let's deal with the squelch. Seem to recall that squelch. So I'm going to, I'll switch the attenuator onto here. So at the moment we've got 0.3 of a microvolt. I'm going to turn squelch to full. Then we'll advance this. 1, 3, 10. Now I want it stronger than that. 30, 100. Not quite as strong as that. That's it. 100 microvolts exactly. That's where I want it. So that's set right. While we've got 100 microvolts on there, let's set the S meter with the preset there. There we go. So bigger signal, we'll bring it in. Now we've got that set properly. So now we'll turn the squelch down on the radio. Turn the signal generator to standby. Advance the squelch to threshold. So it does need cleaning, but I can still judge where it is. There. Switch signal generator back on. Still 0.3 of a microvolt. Right. So I'll find a copy of the manual between today and tomorrow. Obviously I've got Powers of Church services tomorrow, so we'll get on with this and we'll get it scratchy cornered. I don't think we're going to get 4 watts with that resistor. I think we'll up that to a 7 watt resistor, and we'll probably drop it from 3.3 ohms to 3 ohms. So I'll do that, and we'll see why the transmit is so flaky. If I go back to the main meter, I key up, it's just, you can see it's just going all over the place. I don't know whether we've got a duff junction because of that stupid modification, in which case the set's effectively ruined, isn't it, because they're very expensive now, or whether we've got a dry joint. But whatever it's doing about 2.7 watts. So we'll just have a very quick look underneath. I'll turn the power off. 4 possible dry joints. But we've done the receiver. We've got it as near on frequency as we're going to, which is absolutely fine. You know, where the PA transistor is, the heat generated can degrade the soldering. But they actually look alright. But something isn't. Or it's the transistor junction itself. And just some little dry joints in this transmitter line. Now they're 40 years old. Can't see if anything's changed. And the answer is no. Power off again. Anyway, I'll take the ballast resistor out and we'll get that replaced tomorrow. These are not easy to get, these resistors, not the type we want. I've got, you know, like a 1 year lead time on buying them. You just don't know if it was intermittent anyway, which is why one reason they linked it, or whether they thought they were going to get 1,000,000 watts out of the set, which they're not going to get more than 27 megs. It's all going to be on a different frequency. So there you are. One of those silly things that people do. YouTube's full of it, and here's me on YouTube. Right, so we'll come back to this tomorrow, but at least we've done the receiver. Okay, the next day before the first church service, pretty early in the morning. I've done the ballast resistor. I've gone down to 2.9 ohms, and we've put a second-hand coil in from a scrap set. So I've seen kind of it's doing 4 watts ish. Roughly tuned is the best I can. Change that capacitor, which was, but you know, I wanted to monitor the voltage on the case of the output transistor, and it seemed to be trying to go into a short circuit. So we're going to kill the power, because you know what, I think the mounting kit's actually failed on the output transistor. So that would be a good cause for it to be intermittently, well, shorting out to some extent as it generates RF. I should be able to prod that with the test prod with no problem whatsoever. It's probably generated so much heat with the silly linking out modifications, it's killed the mounting kit. Well, straight away the washer is disintegrated. There's a bit of it. So just check that the mica is in place okay. Yeah, it's not the mica one, it's the bushing. The bushing's totally failed. Right, I'll get a new one out of stock. Right, so with a new one, we'll fit that. You know, when you get scrap sets, you nearly always find that the mounting kits have been nicked. Even if the power transistors haven't been nicked, the mounting kits have. And what are they, 25 pence or something? And of course they can degrade like we've got here. There's plenty of heatsink compound on that. So I'll tip the radio upside down and we'll get the rest of the mounting kit out. Not a lot left, is there? Right, power back up. How stable is that? It's still not stable, you know. Just see if we can tune it. You know what? It's got to be the junction inside the transistor. And I'm not surprised if it's had that intermittent short circuit caused by this knackered bushing, and it's had the ballast resistor shorted out. It's got very, very hot. That's what's damaged the bushing, and I reckon it's had an intermittent short circuit against the chassis, and that the junction of the transistor is no good. And it's an expensive transistor. What are they, £16 or something? Oh dear. I think I keep one in stock and then replenish it when I use it. And of course all these shiny ones you see on on AliExpress and eBay, they're not genuine, and they're just the manufacturer of fallouts of audio transistors. So they'll be like NPN or PNP, so they do test out okay. But in actual fact, you'll find they've got some ridiculously high gain because they're really audio transistors. And if you try and push them into an RF circuit, you're going to get about 1/4 watt out of them. And the dead giveaway, if Mitusishi stopped making these in late 90s, early 2000. So now, 20 years later, any which are new old stock are going to be tarnished. You know, they're not going to be shiny and bright and see your face in them. And you know, you see these things on AliExpress, 10 for a fiver or something, and they're all shiny. They're not what they say they are. So there's nothing for it, is there? I've seen it do 4 watts, but it's as intermittent as anything. So we'll pop it back out again. I will just do one final test of the final test, and that's into without the heatsink at all, just in case there is a puncture in the mica. So pull that away from the chassis, power it up again, going to transmit, and it's not there. It's still only doing a silly. We haven't got picture in picture, and I'll put that on. So we're in the 3 watt scale, so it should be banging across, and we haven't got that. So I'm not going to power it up forever. So I think that's where we are with it, I'm sorry to say. So we'll get that unsoldered and the new one put in. Always the kiss of death. Whenever you see the ballast resistor linked out, chances are this is either going to already be knackered or it's something's happened, and you can see what's happened. And it's not like it's been any benefit, as I've said before. You don't get more than 4 watts on 27 megs. You're generating it as harmonics on other bands. And even if you did, it doesn't make any difference to your range. So we can actually see, now I've got this out, I'll just zoom in. Wrong button. Camera 1. Go back to position 1 and start again. So can you see, just going a bit further, that the insulating kit has got so hot that it's actually melted down the face of the transistor. So we'll just look at the gain on this. It won't have affected the gain, it's just one of the connections internally intermittent. Now then, it thinks there's a diode protection between collector and emitter. Well, there isn't. But the gain is 28, which is about what you expect. So when you put a transistor on the tester and you find that the gain is 140, it just isn't going to happen. We can all get the specification book out and look at what it should be, and I think we will do. We'll get that out. So I'll be back in a flash. I didn't go and get the data book. I'll just return this camera to its normal position. what I did do was to get our one and only genuine Mitusishi 2SC2166 out. It does say on this one that it's got protection between wherever, so that wasn't wrong. So it says got a gain of 42, which is probably what we'd expect. Or was the other 28? Now I've got a used one here, which is also in the genuine packet. The legs are too short to go in this kind of set, but it could be useful, which is why it's been hung on to. .23 the gain on that, so you can see where we're heading. So I've got a big packet here from eBay or AliExpress, and it says Japan C2166 and some code numbers, and the gain on this is 60 something, which is actually plausible. But I do know that these aren't RF transistors, because we've put one in a radio before and it then delivers a third of a watt. It hasn't got the protection between. It says current gain 65. I say it's plausible, but it's when the current gain's 100 and something or 200 and something. So the other thing is the writing on those is etched, is laser etched onto the device, whereas on these original ones it's painted on. And I can't say I've ever seen one which hasn't been Mitusishi. Well, they weren't doing laser etching when these were made, and when these were discontinued 20 years ago, this is how they were painted. So we'll put this one in. Which brings me to the next thing. Thermal compound is in the next room. Okay, so that done, and we've now got stability back. Just run through that coil. And that one. We'd like to do 4.4 watts. Set it to 4. Check it on channel 1 and 40. 3.95. 4.05. Let's just detune that. See if we're going in the right direction. So I'll have that at 4. That at 4. There we go. 4 watts throughout the 3. So there you go. That's what happens. That's the course of events. And I mean, it was differing between 300 milliwatts, most of the time doing about 2 watts, occasionally flicking up to 4 watts, and or because somebody thinks they're going to get more power by taking out that ballast resistor when in fact they're not. So it's intermittent. So let's look at low power. 260 milliwatts. 260. If the pen would only work. And then the current consumption 1.37 amps. Quite hefty. We did that. there we go. So we just need to set the meter. Which is banging across and isn't now. So that was full scale deflection, it's now 4. That was now set. We're going to spray some things, and we need to see why PA still isn't working. I don't expect that to miraculously come in all on its own. One, two, 1, 2, 1, 2. I'll have a quick look at that. I'm not going to spend loads and loads of time, because we've spent loads and loads of time on this set already. Somebody's had all this wiring out, and it just makes you wonder. Right, I've got some church services to go and do. Right, I better track down what's going on with this around the PA department. Well, the first thing, we're going to get rid of this temporary power lead and restore the socket that you can't get plugs for. We need to check the reverse polarity diode is in place. It is in place. We need to check that it actually works. We're in diode test mode. Yes, it seems to be alright. So what else can we see? Well, the socket well, hang on a minute, we've got some blown track there, haven't we? Or has somebody deliberately scraped it away because they were going to, or did do some silly modification? Because they love doing silly modifications. Yeah. It's disconnected, isn't it? Now why would they do that? Unless you want to repurpose a socket for some other feature. We may be able to do a Mr. Blobby across there. No. It's a bit of a link across then. It's not like it matters, it's just PA. But I like sets to work with all the features. And PA is a good fault finding tool, as I've shown you on countless occasions. I think we'll be cleaning this board up with some isopropyl alcohol as well. It's pretty dodgy looking. So what we're going to do, we'll use the Cybernet type power lead, which of course is wrong, and carefully put it in the right way around. I think the customer said he's going to do this. Right, so that's my Cybernet power lead connected. So we can see the red's that side. And it does say which way around it is. So we can put that in like that. So remember, it's the wrong connector and it's not polarized. And it powers up. Right. Have we still got receive? Yep. But we've still not got PA. Now, you know when you see something like we've just done, you think, well, we've got a real positive thing there, but you know what? It's also been removed at this end. Yeah, they've repurposed the socket for something else, haven't they? I'm going to see if I can find the eBay listing before bringing this to a close. I won't reveal who the vendor is. I'm always interested as to what people say. Do we think that's the end of the problem?
Testing 1 2, testing 1 2 3 4 5. 1 2 3 4 5 5 4 3 2 1.
Good. Right, so next thing, I'll go and get some service oil with an applicator. We'll clean those controls. Right, we've borrowed the service oil with applicator. At least these are, you're able to get into the track with these type. Not sealed. I think the squelch was the one which was probably the worst. Right, I'll power it back up. Fine. Check PA still works. 1 2 1 2, testing 1 2, testing 1 2, 1 2 1 2. We're not plugged into the socket, so of course it doesn't work.
Testing 1 2.
Yeah, it does. Right, that's that done. Back to CB. We'll just set this VCO and then Bob's your uncle, as they say. Sadly, my friend Bob's in a care home with Alzheimer's. I think he's 73. And I've managed to find the eBay listing for this radio, and he's only paid 30 quid for it, so it's not the end of the world at all, but he'll be paying more than that for the repair. Right, so the far side of this capacitor, which is capacitor 20, yeah, it's not, capacitor 9, and we do this on channel 1. So the service manual says select channel 1 and adjust for 2 volts. So there's the test point. At the moment we've got minus something. Assuming that that is I better just check that this is a floating chassis or not a floating chassis, because I can't remember. So we have a positive prod on the power supply, negative prod on the chassis. We haven't got 13.8 volts. So go to that can, we have got 13.8 volts. So it needs to be between one of the cans, which is an earth point. There's nothing unusual there. There we go. So capacity 9. So it's 2.89. Now remember, I've fiddled with these, so it's not like it's necessarily come like this. But it's working on, you know, I just wanted to make sure it's as per manual. You've got to take the manual also with a pinch of salt, because it doesn't say what kind of meter you're using, as in electronic one or a conventional one like an AVO 8, as we have as the industry standard in the UK. So that's 2 volts. Go into transmit, we should also have 2 volts. We've got 0.9. So adjust the trimmer. For 2 volts. Back to receive. And to transmit. That's fine. Now we go to channel 40. And they expect it to be 5 volts, do they? 4 to 5 volts. Well, it's 3.6. And it's 3.5, and that's in experience normal, so that's fine. We'll put it together. Mr. Chippy's wanted to do an on the air test. Just clean that with isopropyl, that seems sensible. But before we do that, we'll draw this to a close-ish by putting it on the aerial. So I wonder when this set lasted 4 watts. I wonder if this set ever did 4 watts. Or 4 watts on 27 megs. More to the point. One Anna Roger. Remember, we set it to 4 fairy lights on transmit. We know the set's doing 4 watts, but you get 3 bars. So it's totally relative to SWR. If I quickly put that back on the test set, and key up, it's still giving 3 bars. Call me a liar. I'll tell you what, we'll just tweak that so that it does 4. Well, it did do when I set it. It's doing 4.05. So that's now set at 4. So that meter now reading 4. So we'll go back on the aerial, and it probably reads 3. But as ever, it doesn't mean that it's only giving 3, because it's relative to SWR. That's what I was trying to tell you. It's still 3, so I'm there we are. On low power, it will be 1. Right. 19 Roger. They'll be out there all having Sunday lunch. Right, I'll turn the test gear off. We'll just clean this board. Okay, that looks a bit better, having gone over it with the isopropyl alcohol. So here's the listing. I just want to make sure we're not showing the vendor. So there we go. And it says £30 buy it now, and it says nice working order. So on transmit it was varying between 300 milliwatts and about 2.7 watts because of the junction of the transistor being intermittent, because the bushing had failed, because it had been fiddled with and the ballast resistor shorted out to do more power, but that more power doesn't appear on 27 megs. So, you know, that's these silly things. YouTube's full of videos on getting 1,000,000 watts out of a set like this, which of course doesn't happen, and then you ruin the output transistor, which is 16 quid. So, there you go. Not true. Does it mean that when you key it up it just lights up red? I don't know. You see, I don't know what people mean by working, do I? I mean, it would have transmitted to another radio in the same house. Oh, didn't say I could get it back together though, did I? Right, we'll get some screws in it, and then we'll get on the air test going. I was talking about Viz Comic in the last episode, and Mrs. Brady, old lady, singing that hymn in the balloon. Well, I actually played it today for a service during communion, and the lady vicar, who originates from Zimbabwe, said, "Oh, thank you for playing that in communion." Oh, I said, "Did you know it?" "Oh, I did, yeah. Oh, that was lovely." Oh, so it's a shame it's not in any of our hymn books then, isn't it? So, so that went all right. I'm going to do the on-the-air test, and I'll nip into the chapel here, and we'll play that on the pipe organ. I'll do it right at the end of the video, and then those people who aren't interested don't need to watch it. I'm not one of those clickbait people who makes you sit to the end of a video. And the other thing is, with the on-the-air test, I continue to get questions like, is that all you get? There's a 6-mile comparison test. It's not all we get. How far away is your mate? And it says in the blurb, 6-mile test. So I'm not sure whether blurb doesn't show up on all platforms, but because I'm using a desktop computer, I don't do mobile phones, as you well know. They don't work here for a start. Good. Well, there we are. All ready to go. Screw the mic in. Wasn't there mention of that mic on this? Or I wonder if that broke in transit. Interesting. Excellent. Oh, it's talking now. Can't in a Roger.
Yeah, but in the fire soup shed and find a wire to run upstairs to connect so I can watch it up here.
Good. Well, it's talking anyway. They'll be at Nottingham, 35 miles away, but they won't be doing 4 watts. So there you go. Thank you for watching. Amstrad 901, genuine type, Cybernet built PTBM 002F from 1981.